In our previous video, we talked about web scraping, and there are different ways to web scrape. You can use Beautiful Soup, you can use URL open, you can go to a web page and you can right click if you're in Chrome and view the page source, and then copy the HTML into a text file, all ways to gain the HTML that is on a web page. Now, of course, more and more websites are being blocked from web scraping because we are seeing web scraping used to build all this generative AI like ChatGPT. And so, of course, people want to charge money for access to their information and block these web scrapers. So in our previous video, we did talk about how that works. Beautiful Soup, URL open, pulling that HTML, capturing it, and saving it to a file. So in this video, what we're going to do is we're going to pull from that text file, and we are going to, if you didn't in the previous video, you should clean it up. So you can find the code for this at drsephpowers.github.io/BIA. We're under sentiment without neural networks. So we want to understand why is something happening. So in diagnostic analytics, we want to understand why are people behaving the way they do. So we want to understand their sentiment. And working through this workbook here, what we're looking at is if we scrape the reviews or the comments on Reddit, for example, we could then look at why people come to our restaurant, why they don't, why they like certain businesses, and why they don't like others. So that's what we're pulling. And so if we go through this code, in our previous video, we scraped it and we saved it as a text file. And once you've saved it as a text file, then you can pull it in. So pulling from a text file, mount to your Google Drive, then use Beautiful Soup and the HTML parser to bring it in. Okay, that's what we created called Soup Red here, and it was just a bunch of HTML code. Okay, alternatively, if you're just pulling the HTML code copy paste from that page source, you can dump it in and have it look just like this. And so what we can do then is we can find tags in the HTML code that are right before the information we want. Here we found class equals MD, gave us the different reviews, which is what you can see here. And then what we did is we created an empty list and had it pull the text right after that class equals MD, which gave us this review list. And then what we did from there is we then cleaned it up to remove things like the /n that you see because that's spacing when it's scraped. And so we can use this same function we created for text mining in our previous videos, loop through it, and clean up the list. All right, now that we have that cleaned up list, what we want to do in this video is some sentiment analysis. Now, we're going to talk about more sentiment analysis when we do neural networks. And you'll recall we had a discussion when we talked about text mining about different tools for analyzing text. And Word2Vec was a neural network model that considered word order and was used for sentiment analysis. And BERT, bidirectional encoder representation from transformers, looked at word meaning by looking at the similar words that surround words to kind of infer meaning that they must have similar meaning if they have similar words around them, to do things like look at themes and summarize documents. These both are neural network models, and we'll discuss more about this when we get to neural networks. But for now, we can do some sentiment analysis using a pre-trained model that has been created, so we don't have to build our own neural network yet. So to do that, what we're going to do is we're going to use something called Vader sentiment. And the term Vader is valence, aware, dictionary, and sentiment reasoner. Okay. In other words, somebody has already pre-trained a model, and it was trained on social media posts. It's very important to recognize that this particular model was trained on Twitter, which means that if the wording, the phraseology, how people talk is not the same way they talk on Twitter, it's not going to be very good as a sentiment classifier. So just keep that in mind as you're thinking about using it for things, and we'll see that in just a moment. All right, so we install Vader Sentiment. We're going to import NLTK. That was a package we used for our text mining. And from Vader Sentiment.Vader Sentiment, we're going to use Sentiment Intensity Analyzer. So this Sentiment Intensity Analyzer creates a polarity score that identifies whether the words in the review are more positive or negative. So it's already been trained on Twitter, and then someone classified the comments in Twitter as a positive or a negative statement. And so because of that, it's learned that certain words are more likely to mean a positive sentiment and certain words are more likely to mean a negative sentiment. It is not looking at the relationship between words. It is simply looking at words itself, right? So let's look at creating this function. This function is going to look at sentiment of reviews, right? We have all these reviews that we just cleaned up here. Each one of these is a review. And what we want to do is have it take the review, and we want it to use the function Sentiment Intensity Analyzer and give a polarity score for each review. Okay, so it's going to take the sentence and it's going to give it a polarity score using Vader. So let's define that function. Now we're going to create a table of all these sentences. So I've just called it sent table. You don't have to call it, you can call it something else. Okay. Now what we're going to do is we're going to loop through the review list, and we are going to, through this loop, we're going to go through each item in the review list, and we are going to apply this function sentiment to that review list. So it's going to take that list of reviews and go through it one at a time, which is why this really is not necessary, this range len. Go through each piece of the review list, and it is going to find the sentiment for that particular review, and it is going to then determine, based on the ranking it gives it, if what we call the comp cent here, if it's greater than or equal to 0.05, we're going to identify it as positive. And if it's less than or equal to negative 0.05, then we are going to call it negative. And then everything in between is going to be neutral. Mm-hmm. All right, so let's give this a try here. So this compound here, this is a variable that is attached to this sentiment intensity and analyzer, so you don't have to touch any of that. So you can, we just call it something, comp cent here, sentence, compound. We're giving this a compound. So the polarity scores, right, it scores likelihood of positive, likelihood of negative, and then we're combining that or compounding that. So you can leave this all as is, and simply review list is whatever you called your list of reviews. Okay, then it's going to create a table. So we'll start with an empty table and then append to it, and it's going to give us the overall sentiment. So it's going to basically classify the comment as positive, negative, or neutral. So let's do that loop here. Oh, it doesn't like when I do that, huh? I'll leave it as range length. There we go. It's not the best way to code range length, but whatever, easy enough. All right, so for example, review list, item number 4 says, I love Vine styles. So what we can do is we can say, okay, let's apply our sentiment to review list 4. And what we get is we get a score for negative, a score for neutral, a score for positive. And here you can see the variable compound, which combines the negative, neutral, and positive to give it a score. Okay, what we're going to do is we're going to do all of the reviews in our list, and we're going to have it identify which ones are negative, which ones are positive, which ones are neutral, based on this compound score, where if the compound score is greater than 0.05, it's positive. If it's less than negative 0.05, it's negative. Otherwise, it's neutral. So notice our if-else statement here. All right, so we're going to need pandas as PD to create our data frame if we don't already have that loaded. We're going to create a data frame from PD using that sent table that we created with that loop, and the columns are going to be sentiment and review. So let's do that. Then what we can see here is that we can see in our table that we have our sentiment and our reviews. So I love Vine Styles, positive. Vine Styles is awesome, positive. Thank you for supporting, positive. Ziggeren for any cigar smokers, it doesn't identify that as positive or a negative, so it's identified that as neutral. Now, let's suppose that we want to look for all of the reviews that contain the word Kensington. So we want to know the ones where they say this is the best store in Kensington, which is an area in Calgary. So what we're going to do is say, take this table, sent tab is the name of our table here, sentence table. And then for sentence table, let's go to the review column. And these are strings, and we are looking for strings that contain the word Kensington. So do a word search, find me any of the reviews that mention the word Kensington, and let's call that whole thing Kensington, and then build me that new table. So do they like or dislike the businesses in Kensington? Well, every business that mentions Kensington, it likes. We can see the hidden gems in Kensington, 2 great places in Kensington, and how much they love Vine Styles. So you can see here, if we focus on the comments for businesses in Kensington, they're all relatively positive comments. So we could try another area, another topic. Let's see, for example, and I don't know, I haven't tried this before. Maybe there's only one. Maybe let's see, is there anybody that contains Japan? Maybe we're looking for Japanese type restaurants. Yeah, we'll just run it the same here. That's the only one that mentions Japan. What's another example we could look at? Remember, here we have not gotten rid of the capitalization and lowercase. So one challenge here, of course, is that because we have not made it all lowercase, if you run this and someone had a lowercase Japan, you'd have to search it separately. What else? How about steak? I don't know. Maybe there's steak in some of these or not. Maybe there's nothing. Let's see. All right, 1. Silver Sage beef is a neutral comment. It thinks it's the only place I'm getting steaks. It isn't able to, it's not a complicated model. It's not a neural network with hidden layers. So it is very limited in terms of its ability to classify positive and negative. It's going really just based on words and not the context around them. So here's a comment about steaks. It's classified as neutral. But if you look at what it has here, just make a little more interactive table so you can see this. This is the only place I'm getting my steaks from ever again, right? Obviously very positive, right? So just keep that in mind if you're using this Vader sentiment. Let's take a look at a different data set. This is the bargaining data set where we had our survey of union members and asked them for comments about what they would like to see at bargaining. And if you recall, there was an open-ended question, question 16. So take a moment and do the Vader sentiment on the question 16. So first thing we do is, of course, import the data set. And then we need to make sure it recognizes that question 16 is a string. So if we look at question 16, here we have 63 responses, a lot of NANs, but we want to be able to look at the different comments and see if they are more positive or negative. So pause the video and see if you can create this model. So our code here, we would create this empty sentence table, if that's what you want to call it. We create a loop where we are looping through question 16. And for each item in that list, we are going to do the sentiment command. So we want to make sure you have loaded that sentiment function. And then it's going to pull that compound score. And then, of course, we're using that same thing that if the compound score for the sentence is more than 0.05, it's positive. If it is less than or equal to negative 0.05, it's negative. And in the middle, it's neutral. And we're building this table here. That table consists of a column called sentiment and another called response. So we can then create this table. You can then deal with all the NaNs by simply having a subset of the table be the table that does not include, that's the squiggle here, does not include responses that are a string. So make sure we classify as a string that contains NaN. By doing that, all the NaNs disappear. So then we can start to see, are the comments more positive or negative? Notice that it has trouble here because it was trained on Twitter and not on greater data sets here. Because, for example, they want more opportunities for overtime. They want more flexibility. And it sees the word more and it thinks it's a positive statement. More mentoring opportunities must be positive. So notice that it's challenging to use this Vader sentiment on things that are not like social media posts because it doesn't know that language here on this survey. If they're saying I want more of, it's that they're not happy with what they have. They want more of it. It can't tell the difference. So you can see here for the survey, except for the ones where it says my boss is an ass, or you need to pay me enough to afford to commute to this job. Unless they're really clearly negative, it has a bit of a trouble finding the positive and negative. So just asking for more pay, more flexibility, it thinks those are positive statements.